Normalization. So this word, this word is a word that you're going to keep hearing a lot, and the reason that you're going to keep hearing it a lot because it has two meanings in two different paradigms in math, one in stats and another in linear algebra. Just like how we mentioned independence has a different meaning in statistics, but a different meaning in linear algebra, and we're focused in linear algebra explanation of independence. Normalization is similar. So normalization has a different meaning in statistical normalization, meaning making a distribution, making a set of data points behave more similar to a normal distribution by making its mean 0 and standard deviation 1. Similarly, we are making a vector. When we normalize a vector, we make it unit norm. What does unit norm mean? We make its norm 1. Strictly speaking, when we normalize a vector, we make its L2 norm to be 1. Before I move on to how we do the normalization, except I explained verbally, but the formula that follows it is as easy. Let me go present to you some intuitive explanation of what happens when we normalize, or what is p norm, like meaning what shape we see when we're talking about the set of data points whose p norm is equal to 1. I think the simplest one is to start with the circle. This circle has a name. Its name is unit circle because it's L2 norm. It's a set of points, set of vectors, set of data points whose unit norm, whose L2 norm is 1. When we normalize a vector, that can be your weight matrix, the set of weights that you're learning in AI, or your input. When we normalize the input, we push them to live on this unit circle. How do we know that when we normalize it goes to the unit circle? Because if a data point has L2 norm equal to 1, what was L2 norm? Square root of its square root of sum of squares of its indices. It means meaning that x1 squared plus x2 squared square root, meaning 1. So by the definition of circles, the set of points whose Euclidean distance is the same, not the same, but 1 from the origin, makes a circle. Similarly, L1 norm gives you that shape, the one that you see on the left. This shape gives you the set of points whose L1 norm is 1. How do we know that it is the case? Because we know L1 norm was sum of absolutes of the indices. That was it. So we know for sure that 1, 0, 0, 1, negative 1, 0, negative 1, 0, negative 1, they are all L1 norm. There are all points whose L1 norm is equal to 1. Similarly, 0.3, 0.7, 0.7.3, and so on and so forth. Every data point that lives on this has L1 norm 1. I'm not going to dwell on the L1 norm, LP norm, or L infinity norm, but the more important thing for us is when we normalize. That's what I would like you to take from this little video. When we normalize, we take everything on the unit circle. That's it. So what do we do when normalization? When we do normalization, let's say if x is unnormalized, meaning its unit norm its L2 norm is not 1. If we want to make it 1, we just divide it with whatever norm it has. So x hat here becomes a normalized vector. So we call x to be unit norm if its L2 norm is equal to 1.